Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today's subject is See Beyond Contaminants with X-ray inspection technology, and today's guest presenter is Ken Falk from Eagle Product Inspection. So, morning, Ken, how are you?
I'm doing just fine. Yourself?
Yes, great. It's nearly weekend, so we're always Fridays is always a happy day.
Happy Friday. Yep.
Yeah. So where are you joining from today? It's your first time with us, Ken. Whereabouts are you based?
I am based in Ohio, northern Ohio, up about 30 miles from the Great Lakes.
And the weather today?
It's a little overcast and drizzly, but was sunny yesterday and should be sunny tomorrow. So it's all good. If it wasn't for the rainy days, you wouldn't appreciate the sunny days. So
that's true. That's true. That's what we tell us in Manchester, where it's raining a lot, but actually it's quite bright and sunny today. So tell us where you're joining from in the sidebar. It's always nice to see Dimitro, Chicago, Sharon from AZ, Frederick from Canada, Victoria from Nebraska, Nian from Sweden, Ahmed from Toronto. You're all very welcome. I'm going to play the sponsors ads now, and we'll be back in a couple of minutes for Ken's presentation. Okay. Okay. Are you leaving your webcam on, or do you want to switch it off, Ken? It's up to you, entirely optional.
I think if you could switch it off is good. That's right.
Yeah,
switch it off.
Yeah, if you could switch it off then from the top. Just let you know, everybody, that today's webinar is recorded. We'll send you a copy of the recording, a copy of the slides, the certificate of attendance, an hour or so after the webinar. So for now, I'll hand you over to Ken.
Great. Well, welcome everyone. I'm very pleased to see folks from all over the world joining for this webinar. Today we're going to discuss X-ray technology and some of the capabilities that you can recognize with X-ray and some of the things that you can achieve in your manufacturing and quality process. So my name is Ken Falk. I work for Eagle Product Inspection, who we just saw a short ad for. I've been with Eagle for about 8 years. Eagle is actually owned by Mettler Toledo, another ad that you just watched. And I've been with the parent company for over 40 years now, working in a variety of different roles. I've worked in sales and engineering, and I've been a product manager. I've worked a lot in industrial automation with equipment integration, control system design, Spent a lot of time with data integration, collecting information from the manufacturing process and delivering it to MES and ERP systems on a real-time basis. I moved to Eagle 8 years ago, and I am now as a regional sales manager for Eagle. I cover all of the northeastern and midwestern United States and manage multiple rep groups that we have that cover that territory on the local level, and I support them on the manufacturing level. So today we're going to talk kind of beginning to the end about X-rays. And we'll start out with just how an X-ray works, some of the components that are part of the X-ray and how they work together to complete the imaging that's required in the process, and how we apply that X-ray technology to inspect products. That's really the intent of the X-ray for quality assurance and production monitoring. What X-ray is actually able to see. Obviously, we've had experience with X-rays at the doctor or the dentist. What we see in a manufacturing process is completely different, and we'll talk about what is possible and not possible with X-ray. Some of the other things that we can do beyond foreign material inspection, including component count within packaged products, checking product integrity, which could be seal integrity or cap presence, mass fill, our mass measurement, which is comparable to weight, although the X-ray doesn't go about it the same way as a check wear. Fill level control, to be sure from a quality standpoint and a legal compliance standpoint that containers are properly filled. We also can verify package integrity. And X-ray isn't just about food inspection, although that's probably the 80% or more of the applications are food. We actually use X-ray for a lot of inspection beyond food. And so we'll cover each of those items and applications. So how does an X-ray system catch foreign bodies? Well, this is a slide to review what an X-ray actually consists of. So starting with the X-ray generator, it actually creates the X-ray energy, and it's then focused into a beam inside of the machine. We use a technique called a collimator that takes that X-ray beam and focuses it into a single line. As you can see in the graphic, sort of fans out as it comes down from the X-ray generator. In this example machine, that X-ray passes through the conveyor belt and the product and is absorbed by a detector. So the detector is absorbing the X-ray energy and sends the information that it gathers to the software application to be converted into an image. This image then is analyzed through a series of algorithms and configuration in the software to determine if the product is within the identified specifications or not. If not, that product is automatically rejected from the packaging line so that it is removed from the process. This makes the X-ray machine in normal operation virtually unattended. So why use X-rays to inspect products? Well, all of our manufactured products are typically inspected in one way or another, and various regulations require that inspection, whether it's hazardous area critical control points or the Global Food Safety Initiative or just good manufacturing practices, or even standards established by the quality assurance teams in the manufacturing process. So X-rays really are best at seeing dense foreign bodies, and those would include metal, glass, bone, stones, high density plastic or rubber. Basically, it's looking for a dense contaminant that doesn't belong in the product. I mentioned the software. The software is really the key to the performance of the X-ray itself. So Eagle software is called Simultask, but what the software does is it collects information from that detector, which is basically a diode array, and it converts that information into an image. And we'll go into some more detail about how that imaging happens and some of the variations or options that are available in the detectors. So the key to that imaging software, one is speed, because these products are moving down a conveyor belt. They never stop. So unlike your X-ray at the dentist or the doctor, you're sitting still, the X-ray is still, it has a chance to take a still image. In the manufacturing process, everything's moving. So that package passes in front of the X-ray beam at a very high rate of speed, sometimes up to 400 or 500 feet per minute. So it can be a very short amount of time to create that image, analyze the image, and react to what we learned from the image in that processing. Also, that image information needs to be saved. So if you have rejected products, typically we want to save those images so that you can analyze them later, find out why the product was rejected, find the contaminant that's in the product, and determine what type of contaminant it is so that you can potentially search for the source. Or in this example, you can see a chicken bone in a chicken breast. You certainly don't want that to go out as a boneless breast. So you want to be able to find that bone, remove it, and run the breast through again. Because of the versatility of the X-ray, sometimes we don't have a single product running on the conveyor belt. Today, as demands are put on manufacturers by some of the larger retailers, it's difficult to install just from a space standpoint, difficult to install an X-ray machine on every single filling line or packaging line in the facility. The space just isn't there, aside from the cost. So frequently we'll have mixed product running into the X-ray. So you might have 3 packaging lines feeding a single X-ray, one because the X-ray is very fast, and then we can switch automatically between those products as they enter the X-ray. So we can do that with barcode, or in some instances, we can just use the image of the product to tell the X-ray what this product is, apply the right algorithms to analyze that image, and allow it to be accepted and rejected accordingly. So the technology consists of 3 basic components, which we started with in that initial graphic. So the physical machine. So the machine itself is tailored to the process or the product that we're inspecting. So X-ray machines come in various styles. In the initial graphic, we showed what we typically call a pack machine or a packaged product machine. Those machines have the generator mounted at the top, the detector under the conveyor belt. The product passes down that conveyor belt between the generator and the detector, and that image is analyzed. Other times, because of the nature of the products, maybe you have bottles or tall jars. It may be more practical to look at that container from the side instead of the top. You have a lower cross section, and in those applications, we can frequently avoid the conveyor belt altogether because the product is already running down your conveyor belt. The X-ray can basically straddle that, look from the side, and then we have the generator on one side of the conveyor, the detector on the other, and the X-ray beam passes directly through the product from the side. So the generator and detectors are also available in a variety of different combinations, depending on the power that we need to penetrate the product, the types of contaminants that we're looking for, the characteristics of the product itself, all have to be addressed in selecting the right generator and detector combination. We'll talk about that a little more as we move along. So I mentioned Simultask. This is the Eagle imaging software, but all X-rays have imaging software. And that software is critical to the task because it is reading the raw information from the detector, using it to create an image, and then applies various algorithms to that image to determine if there are any anomalies present in the image for the product that we've just collected. It also has to do that at very high speeds. So there's different types of technology. We mentioned we have a generator and a detector. So most X-ray machines are single energy. There's a single wavelength of X-ray radiation coming from the generator, which, by the way, let me address that right away. When I say radiation, this is very low level X-ray, much lower doses than you would be seeing at your doctor's office or the dentist office. And I usually joke that when I fly from Ohio to Florida, where our factory is, I get more radiation exposure on the plane than I do operating an X-ray machine. So very low radiation. So dual energy, we have a certain, actually two bandwidths of radiation coming from the X-ray, and then we have two detector arrays underneath that. So what we use that for is if we have a product that is not like a nice homogeneous cup of yogurt or bottle of juice, maybe we have a product like this example that's showing a packaged salad. Now, if you look at that X-ray image, there's a lot of varying density, some very low density areas, higher density areas, because of the mixed product that's in there. Beyond lettuce, you might have carrots and cucumbers and cabbage. And so you have what we refer to as a busy image. When we use dual energy, we use the first diode array in the detector, which is mounted directly above the second. And we use that to filter out the high energy signal, kind of the product signal itself. And we subtract that product signal from the data that we are collecting from the second detector array, which gives us a much cleaner image because we've subtracted the organic material from the inorganic material in the image. And you can see in the example below, in the total image, it's very difficult to see the contaminants. After it runs through the dual energy that we refer to as MDX, material discrimination X-ray, now that set of contaminants is really amplified, very easy to see in the image, and very easy for the X-ray algorithms to recognize and address. There's a newer style technology that we've had out now for about 3 years. We call it PXT, Performance X-ray Technology. So this technology was originally developed to find very small bones in poultry. Chicken bones, as you can imagine, are difficult to find, especially because the birds are typically very young. There's not a lot of calcification in the bone, and yet boneless poultry products are a very common offering to the consumers. So the ability to find small bones in a boneless breast or ground poultry is a critical requirement. So this PXT technology that was developed actually includes both the single energy and the dual energy MDX technology, plus a third technology, where instead of having a single row of diodes, so we're actually looking at less than a millimeter's width of the product as it comes through and passes over that diode, and building the image 1 millimeter wide at a time until it's complete. PXT adds more to that. With PXT, we have multiple rows of diodes, not just one above the other like in dual energy, but side by side. This allows the package to be scanned, the same area of the package to be scanned multiple times as it passes through the X-ray. This allows us to focus and refine that image much more precisely. And today we can detect contaminants much smaller than were ever possible just a few years ago. So again, it started with small bones for poultry, but today we can also see small pin bones in fish that were not visible before to the X-ray. And we're able to see much smaller contaminants, even in much larger packages than we could previously. So in the past, where we had to inspect individual packages, individual, say, pouches of cookies, now we can inspect those cookies in a case using the PXT technology with virtually identical detection specs, which saves number of machines and geography inside of your manufacturing plant. So dual energy, I mentioned previously. So one of Eagle's application focuses is meat inspection. So that's really where Eagle began, was in red meat inspection for beef and pork, more recently poultry and seafood. So we have another dual energy technology we call DEXA, which is still dual energy, but we use it for fat analysis. So when you buy a package of, say, ground beef in the local grocery store, and it says that it is 80% lean, this is the machine that does that. You can run ground beef or beef trim or pork or poultry down a conveyor belt directly through the X-ray machine that's equipped with the DEXA technology, and the machine will determine the fat-lean ratio in that product as it passes. So this is not random sampling. This is 100% inspection and determination of fat-lean, and that data can be accumulated by batch. So if a manufacturer is trying to have a certain fat-lean ratio in the sausage blend that they're creating, this machine can tell you for this particular batch, it keeps a running total of the weight that's gone through, and it tells you exactly what the fat-lean ratio is for that batch that you've just run through. And it's also inspecting for contaminants at the same time, which can be rejected from the product flow as it passes through the machine. Now, this isn't just applicable to bulk product running down a conveyor belt. We can also do this in frozen cartons. Frequently, internationally, beef or lamb or pork is shipped in a standard size carton and frozen. So this technology can work on those cartons or in the bulk as the product runs through. So after the X-ray machine detects a contaminant or an overweight or some other anomaly in the product that we're inspecting, the idea is to remove it automatically from the process. So to do that, we use a whole variety of different types of rejects to achieve that. And frequently, just as we go through some effort to apply the correct generator and detector, it's also important to select a reject that is capable of operating with the product in the configuration that it is at the speeds that it is traveling. So it's very important to properly specify the reject that we're going to use. So these are a few of the different types. Air blast is simple and easy to understand. As the package passes in front of the reject, the air blast is fired and blows the package off of the conveyor belt. Now the air blast reject with the X-ray, we can control the timing from after we image the product till it reaches the air blast. So it can be in varying distances downstream from the X-ray. And we can also control the duration of the air blast. So depending on what the product is, maybe we need it on longer or shorter. We do all of that based on the imaging scan measurement, so that we're not trying to measure the belt speed, we're measuring the amount of time that it took for the object to pass. And therefore, we can even focus on just the contaminant itself. So if we know that the contaminant was at in a bulk, we can focus on just that area of the product where the contaminant was located. The next one, deflection flap, we typically use that for bulk products. So if you had, say, an X-ray belt that was, you were running peanuts down that belt, we can still look at a belt full of loose peanuts, and as they pass through the X-ray, we can see specific contaminants that may be sitting and mixed in with that product. Dual energy, by the way, is especially handy in that application because of the busy image of loose nuts. But the deflection flap, now that is actually set up with multiple flaps across the end of the conveyor, so that if we see the contaminant is in the far right side of the product as it passes through the belt, we can move just that one flap and reject just a small area of that bulk that's running on the conveyor. The drop gate is typically used with products that are not easily moved with a pusher or an air blast, like say a bag product. If you had soup or sauce in a vacuum sealed plastic bag, sometimes that's hard to push. The air blast doesn't work as well. So a drop gate allows us to drop out a section of the conveyor and let the product transition down into a reject bin that sits underneath. The lift gate, very similar, except instead of the gate dropping, it lifts up and allows the rejected product to run underneath it. Push arm is common for packages, cartons. It basically actuates and pushes the carton off the conveyor, usually to a conveyor on the other side, or into a reject bin where the rejected product can be isolated and contained. Most reject bins are lockable so that they can only be accessed by QC, so they can inspect the rejected product and determine next steps. Retracting nose, so that's basically a short conveyor, but the leading edge of that conveyor actually pulls back to let product drop in front of it and then closes again. We use that frequently for bulk meat. So now you have a conveyor full of beef. It's kind of water falling onto that reject conveyor. If we have a contaminant that we want to reject, we pull the conveyor back, let it fall through, close the conveyor again, and it continues. The tall servo. So on the products I mentioned, sometimes we have an X-ray machine that looks from the side. We call those machines tall machines, not because the machine is tall, because it's designed to work with tall products like bottles and cans and so forth. Frequently, those containers are glass. And to inspect glass, and by the way, we do that very well with X-ray, we can find a piece of glass in a glass jar going by at very high line speeds. The trick is usually, how do you reject a glass jar that's going by at very high line speeds, some at 1,000 pieces a minute? So we use a servo. So the servo can actually reject up to 1,200 containers a minute. It's very fast to actuate, and we can control it by adjusting the acceleration. So if we're pushing on a glass jar, we're not whacking it like a baseball bat. We actually accelerate until we make contact, push it off the conveyor, and then we can retract very quickly. Poultry short nose retracting. What really makes this a poultry reject is that it is all hygienic, sanitary construction. That is critical in applications where you're handling raw product directly on the belt. This reject is basically a retracting nose like you see the other one, but it is designed to be disassembled easily by hand, no tools required, for complete cleaning which they typically do on a daily basis, and then completely reassembled by hand very quickly. So beyond just foreign materials, we alluded to some of these things already. The X-ray is capable of inspecting a variety of different characteristics of the product. And I mentioned before we could have mixed product on the belt. So say 3 or 4 different products running one right after the other, sorting them, or identifying them with a barcode scanner so that we can inspect them. X-rays can also run multiple lanes. So I could have 3 lanes of burritos feeding the X-ray machine, all running side by side, being inspected individually, accepted and rejected individually, all running at line speeds. They don't even have to be all the same products. I could have, to stay with that theme, a burrito running in one line, a taco running in the other line, and a jar of salsa running in the third line, all on the same X-ray machine, all at the same time, collecting data and accepting and rejecting all of those simultaneously. But it's not just contaminants. So we can count components. We'll look at that a little more in an upcoming slide. Product integrity, some of the quality characteristics we can inspect. Fat analysis, I mentioned that earlier, and we'll look at some of the other things we get during that process. Mass measurement, so we can actually determine weight of a product running through the X-ray with certain limitations. Fill level, so when we look from the side, we get a very good view of that container and the product inside. You can tell if it's properly filled. And package integrity. Are the flaps closed? Is the cap on? These are things that we can see clearly with the X-ray. So some examples of these: component count. So we can tell the X-ray, and you can see in this image of the sausage, that there's supposed to be specifically 8 sausages in that package. And if there's not, we can identify that easily and reject that package for missing count. We can also tell when things that are supposed to be in a package are not. In this case, the salad dressing is supposed to have, or the salad kit is supposed to have a dressing pack in the package with it. If that dressing pack is missing, we can identify that and reject the salad because of that missing pack. And in the image that we save when we reject the product, the operator or the quality control person excuse me, can actually look at that image and see why we rejected it. We will highlight it similar to the way it's shown in that image, and you can tell that it's missing the dressing pack, or there was a specific contaminant, and that contaminant will be highlighted with the location. So component count is a good description, but it's more than just counting. Sometimes we're just counting to 1. For instance, this is a contact case that you're seeing in the upper left. And by regulation, it's required that there be an instruction piece in that contact case describing to the user how to use them, care for them, and apply them. We can look at that contact case and tell if that instruction is inside. We can also see desiccant packs in a bag of jerky, or an oxidizer in a package of ham, leaflet instructions in this package of products. Or if you've purchased a box of cereal that's supposed to have a prize inside, we can be sure the prize is actually there. So product integrity, it's not always about a foreign material or something present or missing from a package. Sometimes it's the product itself. So X-ray can see darker, denser objects in a product that don't belong there. But it can also see low density in a product that doesn't belong there. So for instance, if I look at these patties and one of them has a void, which could be literally a hole through the patty, but it could also be a light, low density contaminant that is mixed into the patty that will show up in the image as a void because it's less dense than it's supposed to be in that area. We can also tell if a piece is missing. So in this case, a patty has a section broken off of it. Or we can actually measure dimension with the X-ray. Once we have an image, we can apply all these different algorithms to it to determine if there's some deviation from the normal. In this case, we can see that one of these beef sticks is out of spec by length. Continuing with product integrity, we can see if products are broken. So sometimes you have in this case, a chocolate bar that was broken. You can see that cookies have been crushed, or sometimes potato chips are crushed in the bag. Here's a tube that might contain cookies or crackers. You can see that one end of it got crushed and there's voids present in that tube. All of these are quality metrics that are unacceptable. The X-ray can also support multiple rejects. So sometimes quality will want to manage foreign material different than other quality rejects. So if something was rejected for weight or damaged product or short length or whatever, maybe that goes in one reject bin, or foreign material goes into a different reject bin. The X-ray can actually support dozens of different rejects. Like in that multi-flap application I described, we might have 4 or 6 or 8 or 10 separate flaps that are all controlled by the X-ray. One of the things we're asked to find frequently is voids. So these are areas that are low density. No one wants a void in a loaf of bread, where you open it up, go to make a sandwich, and you've got a huge hole in through several of the slices of bread. So we can see voids in a loaf of bread as it runs through the X-ray at high line speeds. We can also see if product is broken in the packaging, in this case, the cookies, or if foreign materials such as a wire tie are trapped inside the product as well. All of this is possible. The X-ray just has to be set up to look for it. So with fat measurement, we talked about being able to see the fat lean ratio, but this actually provides information beyond that. So we can see not only the current what's called chemical lean, CL value, which is very accurate to ±1. We can also measure the fat as a percentage, the current protein, the moisture, and still check for contaminants inside the product. So in the screen that you see here, this is an actual run screen off of the Eagle FA3, and it is showing how much product is run, how many rejects we've actually had, the current chemical lean value, 91.12, the current fat percentage, and the accumulated weight that is run through under this particular batch. So the fat analysis system is not only applicable for your production, it's also applicable if you buy meat from a vendor. And when you do so, you're typically paying for lean. You're paying for 90% lean or 73% lean or 50% lean. You want to be sure that you are receiving what you're paying for. So you can use the fat analysis system to inspect incoming product to verify that you in fact received 90 when you paid for 90. This allows you to put together sort of a record of what vendors provide a consistent product to you based on the history of monitoring their deliveries. And that statement, I should say, is accurate for X-ray overall. We usually focus on quality inspection at the end of the line for obvious reasons. Once the package is sealed, there's no opportunity for a foreign material to enter that package. But it's also important to determine if there's foreign material in your process as early as possible, so that if you received contaminated product as raw material, before you invest all of your time and capital into that product and produce the finished good only to find out it was contaminated upon receipt, it's better to know if it's contaminated early on. So there are X-rays that do packaged product inspection, but also those that do bulk inspection and can even inspect product in a pipe. So if the product is being pumped, we can X-ray it and find foreign material, and not just metal, like a metal detector, which works on conductivity, but we can see any dense item, which could be glass or bone or stone or clamshells or anything that you don't want to see in that product. So mass measurement. So the X-ray machine does not contain a load cell. We actually use density to determine weight. And so when we create that image, we know what the average density, we'll call it grayscale, and that's something else I'll touch on briefly. So the imaging in an X-ray is taking that signal from the diode array that we discussed and creating an image. Well, that imaging capability varies depending on the technology. So many X-ray systems are 8-bit systems. So that's taking that image that was measured by the diode and dividing it into 256 shades of gray. That's kind of the resolution. Some X-ray systems, Eagle's X-ray system, actually uses a 16-bit imaging technology. So that converts that image to 65,535 shades of gray. Huge difference. 256, 65,000. That allows a much more detailed image to be analyzed by the X-ray and allows you to do special things or more things. Think about it when digital cameras first came out and you had a 1 megapixel camera, and today you have a 12 megapixel camera. How much different that image is? That's the same as the grayscale imaging difference. So once we have that, we can determine mass. So if we know that a jar of peanut butter is supposed to be this grayscale average across the dimension, we can calibrate that into grams and weigh it as it goes by at 1,000 jars a minute. Difficult to do even with a checkware. But the X-ray is not just seeing weight, we're seeing the whole product. So in this example, we can tell if this package of donuts, if one of the donuts has less filling than it's supposed to have. Now we can reject the entire box of donuts. The quality people can see the rejected image and say, look, donut number 4 doesn't have any filling in it. The customer would have been very unhappy to buy a jelly donut and not have filling. The data that's provided for mass measurement is just very similar to a checkware. You'll see total products that have run through, total number of products that have been rejected, the average weight, the mean, the standard deviation. You can see product giveaway, how many fell into each weight zone. All of that information is available on the X-ray. We can also determine weight by zone or by area in the product itself. So in this example, we have a 2-compartment ready meal. And on one side, you might have protein. On the other side, you might have a starch or rice or whatever. We can actually get a weight by each one of those zones. That's something you can't do with a checkware, but the X-ray can do that easily. Even if there's more zones, like in a TV dinner where you might have 4 or 5 zones, we can look at that. And it's not only important just for the weight, But if you're providing meals like this for institutional delivery for hospitals or elder care, frequently you're required to guarantee a certain calorie count, protein content, carbohydrate content, nutritional. And if you can't control the fill of those compartments accurately, you may not be complying with those nutrition standards. The X-ray can do this. Fill levels. So fill level we're usually looking at when we look from the side. Now weight and fill level are two different things. We can do either or both. And when you're looking from the side, now you get some information about the product. One, it's a shorter cross section, so you have typically better detection and can use lower power. You're not trying to look through the entire depth of a tall container. And so now you can see if the container is being filled properly. Now, sometimes it's not being filled properly because the filler needs to be adjusted. Sometimes it's not being filled properly because the product has been damaged, like in the example of the potato chips. Now, the X-ray, let's say in this case where you're filling the yogurt or you're filling a bottle with a beverage, the fill level can be measured by the X-ray pretty precisely, usually within a millimeter or two, and feed back a signal to the filling machine that tells it you need to increase or decrease the fill by X number of grams on this container. And again, this can be done at very high line speeds. So zone fill inspection. The other slide we showed two compartments, but let's say you had a 6-pack of yogurt. We can actually look and tell if one of the yogurt cups is underfilled. If you check this on a checkweigher, you may have one that's overfilled and one that's underfilled, so the overall weight averages out to okay, except with the X-ray, we can see that one of these cups is underfilled. We can even see these, if they are stacked in a carton, we can usually tell if one of those cups is missing, so the component count application as well. Package integrity. Well, while we're looking at the product, we see more than just contaminants. For instance, we can tell if the cap is missing on the bottle. We can tell if there's a piece of cheese actually trapped in the edge of the heat seal in the vacuum pack. We can tell if the chub of beef had the clip pop off the end so that it's not shaped properly. And by the way, if the chip blows off and ends up inside the chub, we can see that too. So X-ray can also look at non-food products. Pretty much everything we just talked about is food. And that is probably 80% of the business. But we can certainly see foreign materials, but we can look for things that are not assembled properly. We can see components that are missing or that the package isn't correct. And quite honestly, our applications people are happy when I send them things that aren't food just because they're different. So here is a product that we inspected for the military to determine if this projectile was properly assembled. And you notice there's a pin inside of it, and we could actually determine for them if the pin was properly installed. This is a medical kit that contains a solution along with a rubber tube for the syringe kit. We can tell if that product contains, if that package contains all of those required pieces. Very quickly, without touching the product, as it runs through the X-ray, and kick products off that are not containing all of the components. Here's another one. So this was a backpack leaf blower, and the customer was looking for a way to tell that all of the items required were inside of that carton. They couldn't check weigh it because some of the items they were looking for weighed less than the normal deviation in the package. So they wanted to know, for instance, is the oil bottle, the instruction manual, the tool kit, all inside of that box? Well, with X-ray, you can look into the box and see. In this example, we can tell that the toolkit, which is supposed to be right here, is not present in this package. Same customer, different product. So this is a string trimmer that you would use in your yard. Now they come shipped with 2 in a package. However, this package doesn't have both motors. It has 2 of the other components, but it's missing 1 motor. So we can see this just as they run down the conveyor belt after it's already been packaged. And they weren't able to check weigh in all cases to determine what's missing because of the light weight of the product. Weight verification. So we do a lot of checking packed cases to be sure that something isn't missing. So instead of trying to weigh the contents of a single container, now we're trying to determine if a case actually contains all of the products that it should. Whether it's a sauce cup or an ampule or a bottle, we can actually tell by the density whether or not something is missing. So we do that a lot. If you get cups of yogurt, cups of sauce that might go with fast food, we can look at a whole case and tell if one is missing. So package integrity. So here's the same image again of that syringe kit, but in this case, a piece of the rubber tube is actually sealed in the bottom seal. We can see that type of defect and reject for that as well. So it's more than just food. It's really up to the application and your imagination. Always think, boy, could I see that with X-ray? If you can, it's usually the fastest, easiest way to determine if there's a defect and remove it from the process. So in conclusion, while X-ray gives manufacturers the tools to maintain quality at every stage of production, remember to check at the beginning of the process as well as the end. And we can, by fine-tuning the X-ray, to set up an X-ray to find a contaminant in a jar or a bag is very simple. You can do that with AutoLearn, push the button. If you want to do something more detailed, like measure the length of products or determine if the toolkit's missing in your backpack blower, the X-ray has to be configured to do that. So it's important that it has software that's flexible and allows that configuration, and that you can have one of the experts do that for you. And now we'll move on to some questions.
Okay. Thanks very much for that, Ken. Just one thing to just pop into the sidebar. We have got, there is a white paper, more than foreign body detection. I think you can probably see it in the sidebar, free white paper. If you click the download now button, it'll open a new window. It won't take you away from the webinar. So you click that at any point and you can go and download that over on the Eagle website. Yeah, let's get some questions going. I'll just get rid of the slides. Okay, so first question from Sonia. How often do we need to calibrate the machine, and can it be done by the user?
Okay, so there's calibration. There's actually different degrees of that. So normally every day when you start up the machine, if it's been turned off overnight, it goes through a process that we call normalization. That allows everything to come up to temperature and stabilize before you start running. So that's kind of an internal calibration that the machine does. Once a year, you want to have a service technician come in and inspect the machine, not only for wear and tear, preventive maintenance, but also for radiation. So they have to go and test radiation to be sure they're all within the FDA limits for the machine. And then there's a function called validation. So just like if you have a metal detector, every time you change a lot, or maybe every hour, some period during the day, you'll run product through with a known contaminant to verify that the machine is detecting what it's supposed to detect and rejecting it efficiently. So that is done with an X-ray as well. There's actually a function on the machine called validation, where you hit a button, puts it in validation mode, which all it changes is it doesn't add the rejected product to your statistics. So as far as calibration, there is no calibration like you would do on a, say, on a scale, where you have to put a test weight on it once a day to be sure it's weighing properly. Calibration of the X-ray is done during configuration of the product setup and is validated during the course of the manufacturing process.
Okay, thanks. Question from Unam. Can it detect a worm in shredded lettuce?
So the short answer is no. The X-ray, because it works on density, requires that the contaminant or the foreign material that we're looking for varies in density from the product. So usually a thing like a worm in a bag of lettuce, the worm and the product are going to be pretty much the same density. We won't be able to see the difference. If the worm was even a little more dense, and we could even look for the shape, we might be able to find it, but no, we won't find a worm. You typically also won't see wood or hair or light material like paper or pieces of a hairnet or pieces of a latex glove. They're just not going to be different enough in density for the X-ray to detect them. Our general rule is if the contaminant will float in a glass of water, chances are it's not dense enough for the X-ray to detect it. So a piece of wood, a piece of styrofoam, you're not likely to see that. And that's just physics.
Okay, makes sense. Question from Lampros. What are the limitations in foreign bodies density when packaging is tin plate? That's pretty much what you've just said, isn't it?
Sure. So can we see a piece of metal in a metal can? Yes. We do that quite often. So we run cans of soup, and we're looking for a piece of metal in the can. We can see a piece of glass in a glass jar. Now, it may be the same material, but because there's an extra piece, it increases the thickness and therefore the density in that specific area. So yes, we can still see metal in a metal can or glass in a glass jar.
Okay. Question from Miguel. How big can the product be to analyze? Can the equipment analyze a whole box?
So yes, so there's a variety of different machines. They're really designed based on size. So in our numbering system, we make the smallest machine is a PAC 240. PAC means it's designed for packaged product, and 240 is the width of the X-ray beam in millimeters at the belt. We make a 320, a 430, a 550, a 720, and a 1000. So we can have large cartons up to 1,000 millimeters wide. So the PAC 1000 has a 40-inch wide belt that we can actually inspect large cartons on. So we do that a lot for chips and pretzels and things of that nature that come in large packaging.
Okay. Martin is asking how to differentiate the validation and verification of X-ray equipment.
Well, I described the validation already, and I'm not sure what the difference between validation and verification would be. So we provide with any new machine test cards. So let's say we have a test card for stainless steel. The machine has been guaranteed to see 1 millimeter stainless steel. On that card will be a 1 millimeter diameter sphere that you can use to put into a product or on top of a product or underneath a product that runs through the X-ray and verify that the X-ray detects that 1 millimeter sphere as it's supposed to. You also want to verify that that product got rejected as it was supposed to. There's no point in detecting its existence if you can't remove it from the line. So frequently that's part of the process as well. So I would call that verification. Validation, we specifically use that word to describe that testing procedure, and we save that validation data in a file so that you can recall it either just extracting it off the machine with a thumb drive, or you can connect over the Ethernet port and have that information delivered directly to your PC or server so that you can monitor it and store it real time. I hope that answered the question. If there's more explanation you'd like to provide for validation and verification, I'd be happy to address that. Maybe you can leave that in the chat and we'll follow up with it.
Okay, sounds good. A couple of questions on plastic. So one, what are the size of material that can detect, for example, high density plastic, what sizes? Also the other one, for plastic detection, what are the limits? You mentioned must be high density plastic, but as a limitation about a certain size, accuracy of plastic detection in X-ray machines.
So yes, so obviously we get asked about plastic all the time. Plastic is, okay, I'm reading the question now. Plastic, it really depends on the type of plastic, the size of the plastic, and the product that it's located in. So it's not an easy answer because plastic's not easy to detect. So if you're talking about a broken piece of a link belt conveyor or a piece of plastic pallet or a plastic tote bin that had a piece break off, or even a pair of plastic safety glasses, there's a reasonable possibility that we're going to be able to see a larger piece of that. If you're talking about plastic shavings or a like the little strap that goes between your earplugs, or a small piece of plastic that flaked off, you're probably not going to see that with X-ray. The best way to tell is to let us test your product and provide plastic contaminants that you'd like to verify we can or can't see, and we can do that and help you with that. Plastic's tricky. Some yes, some no. And some changes have been made in the industry. So I mentioned link belt conveyor. So most people are familiar with Intralocks. That's what they make, this link belt conveyor. We actually worked with Intralocks because sometimes that belt breaks off and ends up in product, and it's difficult to see. So we've worked with Intralocks, and they now offer that belting in an X-ray detectable version. Typically, they're adding a component to it like barium sulfite that puts enough density in the product that lets it show up to the X-ray. So I actually have the little test spheres now, like we have for stainless steel or ferrous or non-ferrous or glass. We have Intralocks belting test spheres that we can test on the machine as well.
Very good. Mohammed, do you have any feedback on the use of this technology in the pharmaceutical industry? Example, powder for injection or opaque liquid products for oral use or for injection?
So usually a liquid, we're not going to be, we might be able to see the fill level and we could see contaminants in the liquid, but it's not, and it doesn't really matter if it's opaque or not. It's based on density. So in pharmaceutical, the common applications we have are, like you saw, the syringe kits, blister packs where you have tablets in a blister pack. We can tell if a tablet's present or not present in that blister pack. In a filled container of a liquid, we can tell if there's contaminants there, such as glass or we can see fill level and so forth. So yes, it is We do have pharmaceutical applications. They are less common, I would say, than food applications, but it is possible.
Okay. Ivy, is normalization the same as gain calibration?
No. So gain calibration is something that we would typically not expect the customer to do. So in the setup of the X-ray, there's a number of adjustments that are made, both to the power settings on the generator itself. There's also settings that are made in the imaging settings to be sure we get one-to-one imaging. What that means is if you took something that's like a hockey puck, you put a hockey puck on the X-ray belt, when it goes through, that image should be perfectly round. If the settings are not exactly correct, it will be elliptical, and they have to be tuned to be sure they're correct. That's usually done at installation. The machine is tuned to your specific product and application, your belt speed, and so forth. The gain calibration isn't typically done by the customer. If you have a new product, for instance, well, let's say it's exactly like an existing product, but it just has a different part number. Maybe it's a different flavor. You can just copy and paste that product and give it a new name or a new SKU for that product. If it's a brand new product that you've never run before, you can hit a button on the X-ray that puts it into auto learn. You run the product through 10 times. The X-ray learns the density and configuration of that product and saves it. And then from that point forward, you just select that product from the drop-down list. It automatically configures for that, and you can run that product through. If you have more detailed questions about calibration of the X-ray, I can have someone address that for you from tech support.
Okay. Just a few more to get through. A lot of questions. There always is. Phil, our product is packed in paper canisters with metal end or PET bottles. Can the X-ray detect foreign materials inside these types of package?
Yes, absolutely. So we actually inspect some material like baby formula, some of which are in a paper carton. Sometimes it's in a metal can. We can definitely see metal cans, paper cartons, PET bottles, glass containers, almost any packaging. Unlike some other technology like metal detection. So metal detectors, if you have, for instance, metal end on your paper carton, the metal detector doesn't like that because it's looking for conductivity. Or if you have foil packages or even metallized film packages, the metal detector doesn't like that because it's conductive. Even products where they thaw and the conductivity changes as the product is frozen or thawed. None of these things affect the X-ray. We don't care if the container is part paper and part metal. We can see, as I mentioned, metal in a metal can. We can see glass in a glass jar. Because the X-ray is working on density, it looks through that. If your frozen product starts to thaw, it doesn't matter to the X-ray. It can be frozen, it can be thawed, or any point in between. It doesn't affect our detection.
Right. Question from Ivy, another question. Can it detect foreign material in dark packaging or dark product, example, cocoa or dark soy sauce in the bottle?
Yes, absolutely. So the X-ray isn't looking through or trying to pass light through the product. We can actually see contaminants in a solid if it's more dense than the belongs there. So we don't care if it's cocoa, powdered cocoa in a can, or if it's dark soy sauce in a jar. The X-ray beam passes right through it, and we can see any foreign material that's inside.
Okay. Bernard, can it detect crushed non-product material mixed up, for example, powdered metal crushes of same color as the product?
So we don't care about color. Again, we're just looking at density. I have had some applications where we had metal shavings, and let's say we're trying to pick the brass metal shavings out of the aluminum metal shavings. Sometimes we can see certain sizes of those materials. One, they're difficult to remove or to reject, and it depends almost entirely on the size related to the normal product. So what I'm hesitating here is crushed non-product material mixed up with powdered metal. So we might be able to tell if there was less dense or more dense by looking for a void or something more dense, but that is not typically a good application. And again, we don't care about color because we're not working with light. It's all about density.
Okay. Phil, how accurate is an X-ray detector rejecting foreign materials? Does X-ray falsely reject good products?
So yes, there are. So the X-ray can be very accurate depending on the components that we choose, the generator and the detector. So in some cases, we're rejecting, 0.4 of a millimeter of stainless steel. Sometimes that number is 2 millimeters, depending on the size of the package, the speed that it's traveling, and it varies. One of the things that we always look at is two criteria: probability of detection, which means if I run that 0.4 millimeter piece of stainless steel through the X-ray 30 times, will I see it 30 out of 30 times? That's the whole point. I certainly wouldn't, as a quality person, say my detection spec is 0.4 millimeters if I only saw it, 24 out of 30 times. So we usually have a safety factor there. And let's say we see 0.4 millimeters 28 out of 30 times, but we see 0.5 millimeters 30 out of 30 times. We will guarantee that 0.5 millimeter detection spec. Now, false rejects occur if you try to push the detection spec to the smallest possible size. So you start to reach a point where 28 out of 30 times, I'll see the 0.4 product. But you also might have, 2 times out of 1,000 that it rejects for a contaminant that's not actually there. So we call that false rejects. So it's important to set the machine up, but those are both criteria: probability of detection and false rejects. If the machine is configured properly and you don't push it too close to the edge of the capability, you'll have minimal false rejects. The other good rule of thumb when you set up the machine, so when we look at the image on the screen after we reject the product, it shows the contaminants in the image, and they're all tagged with a colored rectangle. That color tells us which algorithm it was that actually tagged that product, whether it was the large or the small or the wire, and we might be running 25 or 30 algorithms. With that PXT detector, we might be running 40 different algorithms analyzing that image, and it will show you by color which algorithms actually tagged it. If you see that 5 or 6 all got that same contaminant, now you can be comfortable that you're not going to have false rejects, and you have a high probability detection because you had 5 eyewitnesses saw that contaminant go through.
Okay, and Alvaro, can an X-ray detector find foreign objects in packages of frozen fruits, even if these foreign objects are not embedded in the fruit? We just acquired an X-ray detector, but it only finds objects that are embedded in the fruit. The product is packaged in plastic bags or cardboard boxes.
So if I'm understanding the question, maybe the contaminant isn't in the product, it's just in the container with the product. And yes, we can definitely see that. Sometimes when we configure the machine, let's say you have product in a carton, sometimes we configure it so the carton is excluded from the image. Other times we leave the carton in the image, one, to verify that the integrity of the package is correct, everything is closed and the right dimension. But sometimes the contaminant actually dropped into the carton with your already packaged product that's in the carton. And yes, we can definitely detect that. The contaminant doesn't have to be in the fruit. Frozen fruit is perfectly fine for us. And if the contaminant is in the bag with the frozen fruit, it will show up in the X-ray.
Okay. I'm going to take this last question because we're actually 15 minutes over, 17 minutes over. Phil, does the X-ray detector reject foreign materials automatically, or do we need an operator to monitor the machine?
So the nice thing about the X-ray machine is once it's installed and running, it is virtually unattended. The machine is inspecting every package that goes through as it goes through. If it detects a foreign material or a weight variation or any of the other quality parameters that we define, it rejects it from the line automatically and continues to run. So once an hour, a quality person walks by, they look, the display says we have 3 rejects. They look in the reject bin, there's the 3 rejected items, and they can tell why they were rejected and when they were rejected, and all of that's documented. But the whole goal of the X-ray is that it's an unattended device and runs automatically.
Brilliant. That's great. Excellent. So many questions. Appreciate your time today, Ken. Hope to have you back again soon. Very good. Thank you.
Not a problem. And if you send the questions to me, Simon, I'll do my best to address them or have them addressed and returned.
Yeah. So what we'll do is I'll send over the transcribe from the chat, and if there's any questions that we've missed, maybe you could pick up on that. Yeah, that's it. So thanks very much. Appreciate your time today, Ken.
Thank you.
Hope to have you on again.
Have a great weekend, everyone.
You too. Okay, that was Ken Falk from Eagle.